All right, this worksheet encompasses all the exponent rules we should know at this point. So let's take a peek at some of these problems. So the first one is going to be using big base of p with different powers. We're going to be using the add rule. Notice this is a plain p. We have to know there's an invisible one there. So essentially we are just doing the addition of all three powers. So final answer should be p to the sixth. Next one has no outside powers outside the parentheses. So we could group this into coefficient times coefficient, a squared times plane A, and b times plane b squared. And so that now it might be easier for you to see what needs to actually multiply and what needs to happen. But the 2 times 4 just becomes 8. And then a squared times a to the first becomes a to the third. B to the first times b squared becomes b to the third. There it is. Next one, same thing, let's group it. 6 times -3 are the coefficients, and then x squared, x to the fifth, we're going to be using the add rule. Final answer, -18, x to the seventh. And same thing on this next one, group all those coefficients, x to the third, x to the fourth, x squared is going to be using the add rule. Notice this comes out to a -27, x to the ninth. 3 plus 4 is 7, 7 plus 2 is 9. Same thing here, group all these together, x to the invisible 1. And then there's just this one random y. So 3 times 4 is 12. 12 times 6, grab a calculator if you need to for that. You got it, it's 72. X to the sixth, and then just y. No other y's to add an exponent of. B's, we just add up those exponents. 3 plus 4 is 7. 7 plus 7 is 14 plus invisible 1. And then here we go again. There's a negative invisible 1 right here as a coefficient times -2. So all these are multiplying, all these coefficients. And then p to the third, p to the sixth, p to the ninth. We're going to be adding all those exponents. So negative times negative is positive times negative is negative. 4 times 1 is 4 times 2 is 8. And then p to the 18th. Do you see where that came from? C's and h's on this next one. C squared, c to the invisible 1, c to the third. H to the invisible 1, h to the third, h to the fourth. Total of c to the sixth, h to the eighth. You don't need to do this middle grouping step that I'm doing. I just want you to see where it came from. All right, now we're on the subtract rule when we're dividing two same bases. So we've got 3 to the first on top, x to the third on the top, x to the first on the bottom. The expanded form of this would be to see x to the third on top and x to the first on the bottom, where 1 cancels out, leaving us x squared. But the shortcut subtract rule is that we just go x to the 3 minus 1. So whichever way makes more sense for you, you can do the expanded rule or the subtract rule. I'm going to use the subtract rule on this next one. Oops. This leaves us x to the third, y to the fourth. Notice we handle each variable differently. 12 over 6 is just 2. And then we apply the subtract rule to the exponents. Don't forget there's a little invisible 1 down there. 15 divided by -3 is just -5. And then we apply the subtract rule. There's no c's on the bottom to even subtract. 48 divided by 8 is 6. Negative divided by negative is positive. And we're left with x to the 10th, y to the third. 14 divided by 2 is 7. Seven, x to the first power, 2 minus 1 is just 1, y squared. Now this z to the 4 minus 6 is z to the -2. That means in our final answer, 7xy squared stays on top, but z squared moves down because of the negative exponent rule. So that z to the negative 2 in the final step needs to move down to be z squared in the denominator. Negative 3/6 is negative 1/2, p to the 8 minus 2, negative 1 p to the 6th over 2, final answer. All right, 13 minus 23 is negative 10. We don't want to leave that negative exponent in our answer, so the 9 stays in the numerator, but the x to the 10th moves down. Now we've got power to a power. We could do expanded form, writing this thing out 3 times, or you could shower the power like this, giving us x to the 12th, y to the 15th, just by multiplying those powers. If I had done expanded form, I can see that 4 plus 4 plus 4 gives me 12, and 5 plus 5 plus 5 gives me 15 using the add rule in expanded form. So which way made more sense to you? Just doing the power, shower the power rule, or expanding it? This one's going to become x to the 27th, y to the 63rd. Now here it's w to the 9th because there's an invisible one there that multiplies with that 9. 5 to the 3rd, x to the 2 times 3 is 6, y to the 4 times 3 is 12. And I can simplify the 5 to the 3rd into 125 in the final step. 4 to the 5th, x to the 6 times 5 is 30, y to the 3 times 5 is 15. And then I'm going to grab a calculator for 4 to the 5th. It's a pretty big number. Getting 1024, x to the 30th, y to the 15th. Now we've got a fraction that's getting showered the power. It becomes 2 to the 4th over 3 to the 4th. It's not times 4, it's 2 to the 4th power. 2 to the 4th is 16, 3 to the 4th is 81. There's our answer. 6 to the 3rd, x to the 4 times 3 is 12, y to the 6 times 3 is 18. Final answer, 216, x to the 12th over y to the 18th. Negative 2 to the 5th, careful, that's negative. That's also multiplying to the 5th power. X to the 10th, y to the 40th. This is going to become negative 32 on the numerator in the final answer. Let me make more space for this one. All right, x to the 4th to the 3rd, x to the 12th, y to the 3 times 3, 9th, negative 3 to the 3rd, z to the 3rd. Final answer, this all stays the same, is negative 3 to the 3rd becomes negative 27. Anything to the power of 0 is 1, 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 and then there's something here at the back. So this is 1 times 3 to the 3rd, x to the 6th, y to the negative 6 becomes 1 over y to the 6th, 1 over a to the 3rd, 1 over c to the 11th, 1 over 2 to the 3rd. If it starts on the bottom, it moves up to the top, moves up to the top. 6 is already on top. Z to the 8th moves up to the top. A squared already on top. B to the 5th moves up to the top. 3 already on top. Just the x squared moves down. 2 already on top. Just the w 5th moves down. Whole thing moves down squared, 1 over 9x squared. Whole thing moves down to the 5th power, 1 over 32 w to the 5th. Finally, this is the subtract rule, but think of it like, oh no, they're not even the same variables on this one. But these x's on top want to move down, and these y's on the bottom want to move up. So this becomes y to the 7th over x to the 4th. These x's want to move down with the 9 that are already down there. This becomes x to the negative 10, y to the negative 6, so both things end up wanting to move down. X to the, oh right, these two want to move up with the other ones. 8 plus 2 is 10. This one wants to move down with the other 3, y to the 4th on the bottom.